What's up, class? My name is Dylan Brown, and today I will be doing my FRQ mini project. Together we're going to be solving 2016 AP Calc BC FRQ number 2 on parametric/vector particle motion. This is a calculator active problem, so be ready to use your calculator. I am personally going to be using my TI Inspire. Let's get straight into it. Let's start by reading the question. At time t, the position of a particle moving in the xy plane is given by the parametric functions x of t comma y of t, where dx dt equals t squared plus sine 3t squared. The graph of y consisting of 3 line segments is shown in the figure above. At t equals 0, the position of the particle is at 5, 1. Let's start by analyzing what they gave us. So we got the graph of y of t, nice. We got the equation of dx dt, cool, and we also got the initial condition at t equals 0. Let's get started. A, find the position of the particle at t equals 3. So we know that position is a vector quantity, so we're going to have both an x part and a y part for this question. Let's start with finding the x part, x of 3. We don't have the position of x of t, we only have the equation of the derivative, so we're going to have to use the initial condition here to help us find that. Initial condition, 5, 1, x equals 5 at t equals 0. So we're going to have 5, initial condition, plus the integral from 0 to 3 of dx dt. And this will give us x of 3. Plug into the calculator. Zero to 3 of t squared plus sine 3t squared dt. We're going to get 14.377. Cool. Y of 3, a little easier to find because we're literally given a graph of y of t. So pretty obviously we get y of 3 equals negative 1/2, that point right there. So positions of vector quantity, so we're going to set this up. And there's our answer. Scoring. First point. Getting the correct integral with the correct bounds. We're integrating dx dt from 0 to 3, so that's our first point. Second point, we need to use the initial condition. 5, 1 at t equals 0. Got that right there. And then finally, we get another point for getting the right answer, which is that. Some common mistakes. Make sure that you do not forget the initial condition. If you forget it, you're going to get a 1 out of 3. You have to use it. If you just do the integral, you're not going to get 2 of those points, and you're not going to get the right answer. So please don't forget the initial condition. Also, know what you're looking for. We're looking for the position. So we're not using dx dt, we're not using dy dt, we're using x of t and y of t. And if we do that, we should get the right answer. Moving on, B. Find the slope of the line tangent to the path of the particle at t equals 3. So right away, slope of the line, dy dx, and we have to recognize that the formula of that is dy dt over dx dt. So let's find both of those. Dy dt at t equals 3. We're going to use the slope of the position graph. So right here, we see that the slope at t equals 3 is 1/2. So we get that. For dx dt, we're given the equation. So we're just going to plug into the equation, the dx dt equation right here. So that's going to equal 3 squared plus sine 3 times 3 squared is 27. 9 plus sine 27 equals 9.956. Plug this back into the formula. Dy dt over dx dt equals 1/2 divided by 9.956 equals 0.05. Scoring, all they're looking for right here is the correct answer, 0.05. So if you have that, you're good to go. Some common errors. Similar to the first one, know what you're looking for. We're looking for dy dt at t equals 3 and dx dt at t equals 3. We're not using y of t. We're not using x of t. Make sure we know what we're looking for. Also, don't flip these. I know sometimes it's easy to flip them and not even realize it, but the dy dt should be on top. So don't make any careless errors. You should be good. C, find the speed of the particle at t equals 3. So we know speed is given by the square root of dy dt squared plus dx dt squared. We're finding the speed at t equals 3. Fortunately, we've already found dy dt at t equals 3 from the previous question. This is a little trick. Save yourself some time. You don't have to resolve all of them. So this equals 1/2. And then dx dt at t equals 3 equals 9.956. So if we plug into this integral or into the square root, we're going to get 1/2 squared plus 9.956 squared. Do that. And we get 9.969. Scoring for this, we need this formula right here, the correct expression for speed, the square root of dy dt squared plus dx dt squared. And then we also need the answer, 9.969. And if we have all of that, we should be good to go. Last but not least, D. D is most definitely the hardest question out of this bunch because you have to recognize that we're finding the total distance traveled by the particle from t equals 0 to t equals 2. So we know that distance is given by the integral of the speed function on whatever bounds you're using. But in this question, it's very important to recognize that dy dt is not going to be the same on the interval 0 to 2. From x equals 0 or from t equals 0 to t equals 1, dy dt is -2, but from t equals 1 to t equals 2, it's 0. So what we're going to have to do here is split the integral up into 2. The first part being from 0 to 1, and the second part being from 1 to 2. So dx dt is going to be the same for both. So let's just find that right there. T squared plus sine 3 t squared. Don't forget the square root. And then from t equals 0 to t equals 1, that's -2. So plus -2 squared. And then we're going to add that to the integral from 1 to 2 of the same thing for dx dt, because we don't know what that's going to be. But dy dt is 0 on that interval, so plus 0 squared dt. So this is going to have to be done on the calculator. So 0 to 1 of t squared plus sine 3t squared. Don't forget the square root of that, and also don't forget the square root, because this is all in a square root. Make sure you're doing your calculator stuff right. All in the square root plus -2 squared dt. That's going to give us 2.238. Now for the second part, from 1 to 2. Square root of, first part's the same, t squared plus sine 3t squared, and then plus 0 squared, because dy dt is 0 from t equals 1 to t equals 2. This is going to give us 2.112. Add these together, and we get 4.35. Points for this one. First point, expression for distance. This one right here. Got that. Next point is get the correct integral down. Get the bounds right. So make sure all of this is good. If your bounds are wrong on either of them, or if you keep the integral the same, or if you can only make one integral and your dy dt is the same, you're not getting the point there. And then the last point is for the correct answer. So this question is pretty involved. The most common errors you see is people just forgetting to split up the integral. You have to recognize that dy dt is going to change. And if you don't make that realization, you're only going to get a 1 out of 3. Make sure you know the formula for distance. That's also very important. And make sure you plug it in your calculator right as well. It's pretty long. It took a couple calculations. But once you do that, you should get the right answer. And yeah, that's 2016 BC number 2. Some similar questions like this. 2001, section 1, part A. From a while ago, but still a good question. Number 1. 2021 FRQ number 2 was also good, and also 2023 FRQ number 3. All of these are similar, working on similar stuff. So if you were uncomfortable with any of that, please use that, and thank you for listening.